Alright, I'm going to try this again. I had a little technological difficulties the first time. So, number one, to list the possible rational zeros, you just look at the last number, the constant is the c, and the first coefficient there is the d, and you just list all of the factors, positives and negatives that go into that number. So, all the factors of 4, plus or minus 1, plus or minus 2, plus or minus 4. You can see all the factors of 3. And then you just take each of those and put them over each other. So this, all the factors of C over D, and that's your list of possible rational zeros. So it has to be part of that list if it's going to be a rational zero. Okay, number two, with bounds, you're trying to figure out where your real zeros can be found, on the upper end and the lower end. All of them need to be found within this particular, these x values. So it's a guess and check. So I got lucky, let's say, and I tried 1, and that worked. So I plugged in, I used 1 as my synthetic division, and I am using that function, 3x cubed, that same function, of course, this one. And then I'm looking to try to get all positives, and so you can see that, I have all positives there, 3, 14, 22, and 18. And then I'm looking for the lower bounds now, so I try some numbers to the left of 1, so I just started with -1. And let's say I got unlucky, it looks like I did. So I tried -1. I'm trying to look for alternating signs. So eventually I got here, and I'm going to say that this would be the answer because I'm looking for alternating signs. Okay? Alt signs. Okay. And then the Card's rule of signs, looking for sign changes of the initial function, the coefficients anyways. So we see only one sign change, so he would say that you have one positive real zero, and then we plug in a negative x for all of your x's, and this time you have two sign changes, so he'd say you have 2 or 0 negative real zeros. And then the imaginary is whatever's left. So you got to know what you start with. So if it's a degree of 3, you got to figure out where the 3 zeros are. So if you have 1 positive and 2 negative, then you don't have any left. It could be imaginary, so 0. If you have 1 positive and 0 negative, then you got to have 2 zeros out there somewhere, and so they're going to be imaginary. Complex is actually the right terminology. And then for the remainder theorem, I think I told somebody earlier in class today that you could just do f of -2 and get an answer. That's true. It isn't necessarily using the remainder theorem, though. And so you could plug it in and get, you can plug it in and get -132, and that would be your answer. Or you can use division, which is using the remainder theorem. And you can plug in a -2, you can do synthetic division, and it's actually quicker that way to figure out the -132, or at least the same level of difficulty. And then the next problem, 5, is whatever your zeros are, it's x minus whatever the zeros are. So you can see my work there, x minus each of the zeros, and it's degree 4, and we know that because if you look at this 2 minus I, these guys always come in pairs, so you know that his buddy is there as well, and they're conjugate pairs, so 2 plus I is his buddy. And that makes degree 4, because we'd have 4 zeros there. And hopefully you get the work that I'm showing there. Definitely use FOIL, and I think I've got everything shown, so you can kind of check out the work. It's a lot of distributive property. When you get to the last times the last, this part, that's what this is. And then I did it off to the side, 2 plus I, right here. I got 2 plus I times 2 minus I. And you do FOIL on that little part. So 2 times 2 is 4. And then you can just do the last. So I times I, so minus I squared. Remember that I squared is actually -1, so 4 minus a minus, so that's why it's 5. So put 5 right here, and then you can leave it in factored form, that's okay. And obviously, these guys cancel out, and so we're left with -4x, in the middle there. All right. Number 6, when you're looking for holes, you're going to factor, And then if you're able to cancel out any of the factors, then whatever ones you cancel out, that's where there's going to be a hole. So we have a hole at 3. Looks like 3 is what that one is. And then if we want to figure out the y-coordinate that goes with it, we just take a 3 and plug it in. So we plug in a 3 right there, and we plug in a 3 right there, and that's why we get 4/1. So 3, 4 is where the hole is. Number 7, the long division, is how you figure out the slant asymptote. The way you know you need to do that is when the power here on the top is greater than the power on the bottom. That would require long division in the oblique asymptote. So we do long division, and all you're concerned about is the actual dividend, and then the remainder we're not worried about. So your answer here is, what I have, y equals x minus 1. All right, number 8. The first thing you want to do when you're graphing a rational function is look for the vertical asymptote. So you look at the bottom and you notice that 3 is a bad thing. So if you plugged in a 3, you'd be in trouble. So the vertical asymptote is x equals 3. So that's what we have. That's what we have here. So this would be, that's why we got the x equals 3 here. So we're getting this. And then the x-intercept is going to be where you set the numerator equal to 0, and you try to find the zeros. So that's x equals 0. That's your x-intercept, and so 0, 0. The y-intercept is going to be when you plug in a 0 for all of your x's. So if you plug in a 0 for all of the x's, then it would be on the top it would be 0. On the bottom, it would be 0 minus 3, which would still end up being 0. So your y-intercept is also 0, 0. Horizontal asymptotes, that's going to be when you look at the powers, and you notice, when you look at this, the powers are the same. So you just have to look at the number in front. So that's 2/1. So that's why the horizontal asymptote is right here at 2. Y equals 2. And then, does it cross? You'd have to set your horizontal asymptote equal to the function itself to see if there's actually an x-coordinate that goes with that y-coordinate. And when you work this one out, it doesn't work, so we say no. Conclusion, no, it doesn't cross. All right, last problem, number 9, is you set up a volume, set up your function, and your function is going to be x, because that's going to be the depth of your box when you fold up the corners. Then we're going to have, in this case, it's going to be 30 minus 2x, because that makes sense. If it starts off as 30 and you cut off, this much and this much, that's 2x's, so 30 minus 2x, that's that length. And then the other length was 10, but you cut off x and you cut off x, so makes sense. It's going to be 10 minus 2x. So we come up with our function. So here's our function. And I think the best way to do this is just plug it into the calculator and then see what you get. So I just plugged it in for y1 equals, and I use this window. No magical window. You can use lots of different windows. Just so long as when you look at your parabola, you've got, it's not a parabola, but when you look at this piece, you're able to calculate what the minimum is. Because this spot right here is where you no longer, that's one of your zeros, and you no longer have volume at that part because you would be cutting off too much of the corners, and that's exactly where you have 0 volume. So we want to look to see where we have maximum volume. So we calculate the maximum here. So we calculate the maximum, hopefully you know how to do that. You do second calc and figure out the maximum. And this is what I got. I got 2.26, 315.57. So if the question says find the coordinates, or actually the dimensions of the box, one of them is x, so it's 2.26. Now we need to figure out the other dimensions. So take your 2.26 and plug it in right there and right there, and that'll get you the other dimensions. So 30 minus 2 times 2.6, that's where you're going to get this, 25.48. Then 10 minus 2 times 2.26, you're going to get that coordinate. So those are your 3 dimensions for the box. And your max volume is going to be multiplying those 3 together, or just looking at the y coordinate is also the max volume, 315.57. Does that make sense? Hopefully that helps.